Hello everyone. So welcome back to our YouTube channel. Today we have a very interesting topic to discuss, and that is exception handling. It is the power concept that allows us to handle the error and exceptional situation in our programs gracefully. Do you guys ever think how Python handles the error that comes in your program when you run them? So let's write our own exceptions so that we can print the statement and display a user-friendly error message rather than the complex one. Let me give the simplest example of exception handling so that you guys can understand what exception handling is. In our VS Code, I will write the simplest program for understanding what exceptional handling actually is. So let's write a variable x that is responsible for taking input from user, and after that I will just simply print x. So what happens this time when I print x? Let's run our code in terminal window and see what it gives. So it asks for user input. Let's give a number 4, but it prints 4. But what if I want to divide two numbers and the denominator is 0? So what happens this time? Let's rerun our code. First I assign the value x 0 and y 5, and in the print section I write y upon x. So here write y, not x upon y, actually y upon x. So that's why we can check the zero division error. So let's run our program and see what happens this time. Look, it gives the error file print y of x module blah blah blah, and at the last it gives zero division error. So is it the user friendly message? No, it is not the user friendly message. So the basic purpose of exception handling is to handle these kind of error. So believe me guys, it is very useful whether you are a beginner or not. So let's dive into the problem and let's handle the error. Let's look at another problem of exception handling. Here the variable x is responsible for taking input from user. I assign the value to variable y and I want to print the addition of x and y. Let me clear my terminal window and rerun this program so to see the output. But this time I give the string rather than the integer and it shows the error type error. So these are the errors and these are not user friendly messages. So the basic purpose of exception handling is to handle these kind of error and provide a user friendly message on the terminal window so that anyone can understand the issue and resolve the problem. So in this video I am going to tell you how you can handle these kind of errors that we have seen till now through Python exception handling. So with the help of Python exception handling, you can generate a simple user-friendly error message by your own. We will discuss here two basic problems of exception handling and one real-life problem so that we can understand the visualization and the importance of exceptional handling. So let's move towards our first problem here, and that is this division by 0, the undefined error that comes when we enter 0 in our denominator. So if user enters 0 in the denominator, how we can handle that error by the exception handling? So let's see. I have shown you guys the error message that occurs when we put 0 in the denominator. So let's open the VS Code and see how we can resolve this issue through exceptional handling in Python. So the structure of the exceptional handling is the try block and then except, and then we put the final block. Final block is optional block. So the main two blocks are the try block and the except block. In try block, you can enclose the code that might raise an exception within a try block. The except block, if an exception occurs inside the try block, then the corresponding except block is executed directly. You can specify the type of exceptions you want to catch, or you can use a general except block to catch any type of exception. For example, the zero division error, the value error, or any type of error that you want to catch. So let's write our first problem for zero division error. Here I give the variable number which is responsible for taking the input from user as an integer data type. After that I create a variable result and give 100 divided by number so that if user input 0 number then it will catch. If you have any specific exception that you want to catch, then you can write it after the except block, and then you can write the statement that you want to print as a user friendly error message. So make sure to capitalize the first letter of your exception. Here if I write the zero division error, and if you want to catch the value error, so if user enter any string rather than the integer, then it will print the simple user friendly error message that this is then undefined invalid input, please try again. So make sure to capitalize the first letter of your exception, otherwise it will not catch an error. What this example will do, if the input cannot be converted to an integer, then it raises the value error, an appropriate error message is displayed, and if the input is 0, then it will handle it separately by zero division error message. So make sure to capitalize the first letter of every word, each word. If you write zero division error, then there are the three words, and make sure to write the starting of the each word should be with capital letter, otherwise it will not catch the error. So here I will print the statement for the zero division error, that the division by zero is not allowed. Look, this is the simple message that you can print on the screen instead of the complex one. So let's run our code and see what if I write the wrong command here. It will show the complex error or the simple error message. So it asks for the input. I will write here the name, let's say Rafe, and then I hit enter. It says invalid input, please enter an integer. Look how simple this is instead of that complex one. So this is the main reason we use exception handling to handle the errors. So let's rerun our code and see this time what happens when I put 0. So it says division by 0 is not allowed. Look how simple this is. So this is the best way to handle the errors by your own, and it is a user friendly message that you can print at the output. So let me comment these out and run our code, and let's see how Python can handle these error. Let me comment this out. I didn't remove the try block, that's why it shows an error message for syntax. Let me remove this and fix this error. Here it asks for user input, so let's give the input 0 and see. Look, if you compare this error message with the previous one that we print, then the previous one is the easy, that it says the division by 0 is not allowed. This is the main reason that we study exception handling in Python. So it will make our code good and looks better, so that rather than printing the complex exceptions, it prints just simple one line, division by 0 is not allowed. So this is how we handle the exception for the integers or the zero division error. Let's look at another general example rather than the mathematical operation. So the exception handling is applicable in various scenarios. Let's take for file handling example. Imagine we want to open a file and read its content. However, there is a chance that file may not exist. So let's see how exception handling help us to deal with this type of error. Look, although I didn't teach you the file IO in Python, but this is for the exception handling cases. So if you don't understand the mechanism, don't be panic. I will teach you guys the exact way how you can open files and close file in Python. But just look at the exception handling, how Python handles the error rather than the file. For now, let's look at the exceptional handling cases. So here in the try block, I write the variable file. In the file variable, I open the file that is not exist, and after comma I give inverted commas and write R. This is the symbol for reading the file. If you want to write the file, then you write W. We'll explain the mechanism of opening and reading the file, but let's first run our program in terminal window and see how our code will handle error. So it gives the output error, the file doesn't exist, the message that we want to print. Now let's look at the mechanism of our code, how it handles error. In the try block, I create a variable file to open file in read mode. I create another variable that is content for reading the file dot read function, and at the last I close the file with dot close function. So this basically this file is not exist, and we just want to see that how Python can handle this error if the file doesn't exist. So this is how the mechanism work, and let's just move towards the last example, and that is the real practical example. So in the last example, I will explain the mechanism of withdrawing money from an ATM and how Python can handle the error if any exception is raised for the unknown values or the type error, the value error, the zero division error, or any different kind of error that occurs in ATM machine. So let's write our code for this and how we can raise exceptions and handle the error. In this example, let's assume that you are interacting with an ATM and entering the withdrawal amount. So the code is enclosed with the try block and except block. So in try block, the user is prompted to enter the withdrawal amount, which is then stored in the amount block. And then we give the condition that if the entered amount is less than 0, then the value error is raised with the corresponding error message, and if the entered amount exceeds the available balance, so we will create the account underscore balance variable and give the amount. So let's just raise a value error for the relevant error message. If no exception occur, then the code proceed to the process of withdrawal and update the amount of balance. The details of this processing are omitted in the example. This is just because I want to show the exception handling cases. In the next example, we will discuss how the ATM machine works and we will create a code for that. But first, let's understand the exception handling, how we raise value error. So in the if block, I raise value error that the amount is should be greater than 0, and then in the another if statement, I will give the condition for the entered amount exceeds the available balance. If no exception occurs, then the code proceeds to the process of withdrawal and update the account balance, and we will print the simple message that the withdrawal successful, and the details of the processing are omitted in this example. If any other unexception occurs, then it will be called by generic exception keyword with the exception block. Let's write our code for further function. It gives here the error message. This is because I didn't define the amount underscore balance. So let's assign a value 100 for amount underscore balance, and let's check this time. It asks for amount. Let's give the any number less than 100. So it gives output withdrawal successful. Let's give the input greater than 100, that is the amount balance, and see what program gives at the output. Look at the complex value error message that this program gives at the output. Let's write and try an except block to handle this error. The except value error is used to check any kind of value error that occurs in try block. So if this happens, then the program jumps to this except block, and the as keyword is used to assign the exception object to the variable e, and then we will print that variable with the string. This approach allows us to provide the meaningful feedback to the user when a value error occurs, or explaining what went wrong in the specific context of the program execution in a user-friendly error message. For example, if the user enters the number that is greater than the amount balance, then the except block catches the exception and prints an error message like insufficient balance. This will help user to understand the problem and prompts them to input a valid numeric value. By catching and handling the specific exceptions, we can improve the user experience and guide users towards resolving errors or providing valid inputs, guide them in a easy manner so that they can understand their problem and resolve their issues. So that's all for today. Thank you very much.